Hi everyone, this is lesson 3.4.1, and in this lesson we're going to be looking at applying the laws of logarithms. Example 1.
Okay, this question is asking us to evaluate the following by first simplifying the logarithmic expressions. Okay, now we're going to do all of these basically all together here, just because we're just applying the laws of logarithms here, and this is actually going to be pretty quick. So what we see here is subtraction between two logarithms, and subtraction always becomes division, okay, within a logarithm. So this becomes 24 over 6. And so 24 over 6 is just going to be 4. And then just think about the way a logarithm works. The log base 2 of 4 is going to be 2. That's the exponent I got to take on the base to get to that argument. So 2 to the 2 is equal to 4. Good. Now over here, a little bit more complicated. Now one of the things that I want you to know from this or glean from this is there's a little rule that I teach my students, and that's, I'll write it up here. And basically it's 2 steps. Okay, 2 steps should get us 1 log. Whoops, sorry, you couldn't see that. 2 steps to get to 1 log. Now, I don't even always require 2 steps, but 2 steps typically to get to 1 log here. Here, this question right here is only going to require 1 step. Now, the way this works here, and it relies heavily on you being very comfortable with order of operations. But if the logarithm is positive, then the argument, when you put these together, the arguments will end up in the numerator. If the logarithm is negative, like I'm subtracting it, then the argument will end up in the denominator. Now in this case here, I can do this in 1 step then. Okay, this is going to become the log base 6 of, well, in my numerator, I'm going to have 4 times 18. And then because I'm subtracting the log base 6 of 2, that 2 will end up in the denominator. Okay, now where this gets confusing for people is if there's multiple terms that have negatives in them, and then they start thinking about dividing the negative. Well, what ends up happening here is people end up inadvertently putting stuff that's negative up in the numerator. But it's because the mistake that they make is to start at the right and start, for one reason or another, they start thinking this thing backwards. But you always start at the left and go to the right here. So this is going to be 4 times 18 divided by 2. And in this case here, I can simplify that by simply canceling out a 2 from the 4 there. This becomes the log base 6 of 36. And the log base 6 of 36 is going to be just 2. Now, like I was just saying here, here's one where we've got a couple of negatives here. Now, if you start to think about this as, oh, this is division by 3, and this is 2 divided by 3, but then this is 50 divided by 2 divided by 3, well, then you start getting, you do this weird with fractions, and you're flipping the fractions and the reciprocals, blah, blah, blah. But it's because you're going the wrong direction. You don't do that. You start at the left and go to the right. So this is going to be the log base 5 of, okay, well, this is going to be 15 times 50. So here's in the numerator, 15 times 50. This is divided by 2. Now, this next one is divided by 3. Now, what is it that I'm dividing by 3? Well, it's not the 2, it's the whole thing that's come before it. And when you divide this whole thing by 3, that's just like putting a 3 in the denominator. Okay, and so that's why this works like this, and so why it's so easy for me to just put this together in 1 step, put it into 1 logarithm. And so now this is going to become, okay, what do we got here? We can cancel that with that, get a 5 there, 2 is 25, and so we're going to get 125 in there, and the log base 5 of 125 is just 3. Okay, because 5 cubed is 125. Now, this next question, this is the one that truly is the 2 steps to 1 log. The first step has got to be to remove the coefficients. Okay, I got to move those out of the way before I can combine those logarithms together. Before I can deal with the subtraction, I have to deal with the multiplication here. So I'm going to bring that 1/2 up, and this will become log base 2 of 64 to the 1/2 minus log base 2 of 32 to the 1/5. Okay, so that's my first step to move that up. Now, this can then be, well, actually, you know what? I'm going to get lazy here. I can simplify that in this case. I can make that work. Actually, maybe I will. That's what I'll do. So the very first thing I'm going to do is I'm going to deal with that negative here, that subtraction. It is going to become division. So this will end up being 64 to the 1/2 divided by 32 to the 1/5. And that's all within the argument of the logarithm. Now, 64 to the 1/2. Okay, well, that's just 8. That's just the square root of 64. 32 to the 1/5. That's 2. Now, and if you're not comfortable with that, if you're not familiar with that that result there, I just play with it a little bit. You go to your calculator, and you'll see that real quick here. And then 8 over 2 is 4, and the log base 2 of 4 actually was part of a question earlier, and that's just 2. Finally, let's take a look at this one right here. Same sort of a thing. We've got 3 log x minus log x squared. There's a coefficient here, so again, this is that 2 steps to one logarithm. First, move that exponent up. So this is going to be log x cubed minus the log of x squared, and then subtraction becomes division, so this becomes the log of x cubed over x squared, and when I cancel those subtract exponents, I'll just get the log of x. That's all I'm looking for there. So, like I said, I really want you to be thinking about this in terms of 2 steps to one log. You're really going to see a context for that when we start to solve logarithmic equations. While that will really help steer you away from some very predictable errors in that process.
Example 2.
All right. This question right here simply asks us to write the following as a single logarithm. The previous question was about evaluating. This one here was just about putting them all together. Now, remember what I said before here. We're still thinking about this as 2 steps, okay, to get to one logarithm. And as I said before, this is getting us prepared for solving equations here. Now, my first step is going to be to get rid of coefficients. So this is going to be the log of a, there was no coefficient there, plus, okay, that 1/3 is going to be bumped up, so this will become the log of b to the 1/3 minus, okay, here's a coefficient that's going to get bumped up, log of c to the 5th, okay, minus the log of d. Okay, now here's an interesting one, because this is d to the 6th, and I'm going to bring a 1/2 up. Okay, so and remember, these are going to be multiplied together. This is going to end up being a power of a power, so we're going to multiply those together, and that'll just be d cubed. And then we're going to have this plus, whoops, I have no idea why I wrote that without an O, the log of d. Okay, so now that was my first step. Now, I should be able to combine this all into one logarithm in one more step. There was my first step. All of my coefficients are gone. Now, here I go. And remember how this works. You start on the left and move right. So this is going to be, okay, a in the numerator because it's positive. So a in the numerator times b to the 1/3. Okay, divided by, that's negative. Okay, subtraction becomes division. So divided by c to the 5th. There we go. Divided by d cubed. Now, again, don't start thinking this weird on me here, okay? Don't do that. Don't start making this a fraction here. It's this whole thing divided by d cubed. So that's just going to put d cubed in the denominator. And now this addition here is multiplication, so that d goes in the numerator. So now we've got it all as one logarithm here. Now it's just a matter of simplifying, and there really isn't a whole lot that we can do about this. But this is going to end up being b to the 1/3, okay, and then this will end up being c to the 5th to the d squared, times d squared. Okay, and there you go. b to the 1/3, c to the 5th, d squared. Good. Now let's take a look at this other question here. And in this case here, we're going to quickly move that 3 up into the exponent, so this will become log base 2 of x to the 4 minus the log base 2 of x cubed plus the log base 2 of the cube root of x. And then we're going to combine these. Okay, subtraction becomes division, so this will become the log base 2 of x to the 4 divided by x cubed, and then again addition becomes multiplication, so the cube root of x. And then actually we can simplify this real quick. X to the 4 over x cubed is just going to be an x up here, and when you multiply those together you'll simply get log base 2 of x to the 4/3. And that's all we need.
Example 3.
All right, this question asks us to expand each expression using the laws of logarithms. So really, this is going opposite to what we have been doing in the previous couple questions here. So we're going to apply the laws of logarithms to take what's inside here and spread this out as far as possible. So I'm going to be log base 4 here. But now, if you think about what I had said before, anything that's in the numerator is simply going to have a positive sign to it because these are multiplied together. Okay, so this is going to become x to the 5th plus log base 4 of y squared. Now, I'm going to subtract the log base 4 of 16. And now think about this. The z is in the denominator. I'm dividing this expression by z. So don't think of this as 16 divided by z. No, think of this as the whole expression divided by z. Everything up to this point is all together. The z is in the denominator, so I'm going to subtract the log base 4 of z. You got to keep in mind order of operations, and that always implies that we're starting from the left and moving to the right. Now, to finish this off here, I'm just going to bring the exponents down. So this will become the 5 times the log base 4 of x plus 2 times the log base 4 of y minus, now I like this one here, and when you can do this, you should. The log base 4 of 16 is just 2. And then this will be minus the log base 4 of z. Okay? So whenever you can evaluate an expression like that, you really should. Now let's take a quick look at b. Okay. Notice here in this case that since the base isn't written, we know that that's got to be base 10. And now the same sort of thing as we said before. Anything that shows up in the numerator, okay, when we split these things up, these become the arguments of positive logarithms. Whatever's in the denominator is going to be negative. So this is going to end up becoming the log of 100 plus the log of, okay, well, instead of writing that as the 4th root of x to the 5th, let's just put that all in the exponent, because I'm going to be moving that around a little bit here as well, in a little bit anyway. So this will become to the 5/4 minus the common log of y cubed. And now my next step is going to be to bring down the exponents. Just like it took me 2 steps to get to 1 log previously, I should only take me 2 steps to go backwards and split this all apart here. Now, the log base 10 of 100 is just going to be 2. Here I can bring the exponent down, 5/4 common log of x. And here bring down the 3 minus 3 times the common log of y. And that's what we're being asked to do.
Example 4.
All right, now this question tells us, it says here, if log base to a of 3 is x and log base a of 2 is y, find an expression for each of the following. Okay, now, we have seen these questions before, and I've shown you prior to this point here that there are 2 ways to go about doing this here. Now I really want to focus on that second method that I was showing you in those previous questions here. So notice that what I've got here, I've told you that the log base a of 3 is x, the log base a of 2 is y. So what I want to do here is I want to take this expression, I want to split it up so that I'm finding the log base a of 3, the log base a of 2. I know that there are other ways of doing this, okay? But for right now, in this context right now, this is all about expanding logarithms. So I want you to see this as the log base a of 2 times 3. Okay, and now we know that multiplication becomes addition. Sorry, multiplication within a logarithm becomes addition between logarithms. So this will end up being the log base a of 2 plus the log base a of 3. And now I can make my replacement here. Log base a of 2 is x. Log base a of, log base a of 2 isn't x, that is y. Log base a of 3, that's x. So I get y plus x, or x plus y, because order doesn't matter when you're working with addition. Let's take a look at this one. This is b. Log base a of 8 over 9. Okay, again, what I'm wanting to do here is to use my log laws to expand that out and then see if I can find those logarithms in the question here. So division, I know, is going to become subtraction. So this will become the log base a of 8 minus the log base a of 9. Now, I'm still looking for those arguments, the 3 and the 2 here. Well, I can see right now that 8 is a power of 2. That's 2 cubed. And 9 is a power of 3. That's going to be 3 squared. So now I haven't really done anything. I've just changed the way those arguments look. But now I know that I can bring those exponents down. Okay, and so this will become 3 log base a of 2 minus 2 log base a of 3. And this is what I really wanted. Now we got to talk about this for a little bit here. Because log base a of 2, that is y. So this becomes 3y. Now, this expression here becomes 3y. This one here is equal to this, is equal to this. Now, it's very tempting for people to make this y cubed because you see the log base a of 2 right there. However, it would be y cubed if it was the log base a of 2, bracket, bracket, all cubed. But it's not. You got to look at this and think, well, what's being cubed here? Well, it's just the 2, okay? And when we go back up here, log base a of 2 equals y, not the log base a of 2 cubed, just the log base a of 2. So I got to get rid of that cube, and then I can make the substitution. Just like over here, when I substitute that in for x there, I got to bring that exponent down because the square here isn't over the whole thing. It's just over the 3 in the argument. And so I need to bring that down. And then I can make the substitution. Up here, question C. Very similar sort of thing here, except what I want to do here, first of all, is bring that exponent out. Okay, remember, this is 36 to the 1/3. Well, I want to bring that out first. So this will be 1/3 log base a of 36. And I know, okay, that that 36 is going to be 6 squared. And the reason why I write it like that as a power here is because I know I can always bring that exponent down. So this is going to become 2/3 log base a of 6. Now, the benefit that I have to this right here is I already know that the log base a of 6 is going to be y plus x. So I can actually come at this point right here and I can make my substitution. Now, watch this. This is incorrect, okay? Because the 2/3 is being multiplied by the log base a of 6. At this point here, the 2/3 is only being multiplied by the y. But log base a of 6 is y plus x. So in order to communicate this correctly, I have to put parentheses around that. And so now I know that the 2/3 is being multiplied by that binomial. And now finally this one right here. Now this one here is, you're almost being baited a little bit with this question. Okay, we're tempting you to make this make a mistake here. This division is really separating these two logarithms. Remember that division within a logarithm becomes subtraction between two logarithms. But if you've got division between logarithms, that's a different rule altogether here. And it's not what we're looking at, trying to look at here. This could be considered a change of base formula here. But because we're trying to rewrite these things in terms of x and y, really what I have to do is I have to expand the numerator and denominator separately. Treat them as two different expressions here that are divided. So this is actually going to become I'm going to expand out that numerator here. This will become the log base a of 16 plus the log base a of a cubed. That's all going to be over the log base a of, well, okay, 27. Remember that I'm looking for 3's and 2's here in the bases, and so I know 27 is 3 cubed, so I can deal with that in a bit here. Log base a of 16, well, that's going to become log base a of 2 to the fourth. I probably should have done that to start off with, but I was more focused on this actually when I was writing that out just a couple seconds ago. Log base a of a cubed, because the bases of the log and the power here are the same, that's just going to become 3. All over, bring the 3 forward, so this will become 3 times the log base a of 3. And I really should have done the same thing up here earlier. This becomes 4 times the log base a of 2, plus 3 all over 3 log base a of 3. Whoops, sorry, can't see that. And now, because I've brought the exponents out, now I can make the substitution here. Okay, the log base a of 2, we know from the question here that that's just y. There's the 3 there, and then this is going to be 3x, because log base a of 3 is x. And that's the expression that we were looking for.